You shall see the power of the force in this third of 5 planetary transmissions and motion physics.
Forces have vector qualities. That means that they have directional components. You can pull against something and it can pull equal and opposite, so that the two forces stalemate. That would give a net force of 0. In other words, the two forces cancel out. You can also add a force to a direction by pushing on something already pushing in the same direction. For example, 2 people push on a car might get it to move when one person pushing on it isn't enough. 2 forces of 4 and 5 newtons, both going the same direction, results in a net force of 9 newtons. The common English usage of the word work is a misnomer, like when a teacher says, "Get back to work." They're implying that you should have a book open and pay attention to whatever you're reading or writing. Or a boss yells to their employee, "Get to work," and they mean sit back down at the desk and stop shooting baskets. Neither of these are really work, because work is measured by the distance that a force is applied. That means movement is required in the technical sense of the word. So shooting those baskets or getting out of your seat to talk to somebody else is really the work. The units are Newton meters or joules. A joule is named after James Prescott Joule, who used an extremely accurate thermometer to measure tiny temperature differences in water being stirred by paddles connected to a long cord with heavy kilogram masses attached. These masses would pull the cord by gravity, causing the mass to fall, which then would cause the paddles to spin, and the friction would raise the temperature proportionally to either the distance the cord moved or how much mass was added. The amount that he changed the length in meters was equivalent to the amount the mass changed in kilograms to cause a 1 degree temperature change. That means the movement of a meter did the same thing that an addition of 1 kilogram mass would do for the temperature change. So that's why we now call it a joule. If you want to find out how much work you did when you climbed 20 stairs 20 centimeters high and your weight was 200 newtons, the calculation would be 2/10 of a meter. This comes from 20 centimeter stair height times 20, because there's 20 stairs, times 200, because your weight is the force you're moving, equals 800 joules of work. Power is the work done divided by the time it took to do the work. So if you ran those stairs in 20 seconds, then your power is calculated by dividing 800 by 20, which equals 40 Newton meters, or joules per second, or watts.